Okay, welcome back. This is my Algebra 1 CT lesson on functions, section 1.7. A function is a type of relation. Remember how a relation is a set of numbers and it's usually defined as a set of xy pairs. This can be like a list or a bracketed, here's all the x's, here's all the y's. Any of our function or interval notation will do. So any of our relation or number set or rotation, yeah, or interval notation will do. This is also a video, that reminds me, so you can pause to take notes. If I go too fast, you can watch it in high speed or low speed or whatever you like. So I'll try to go kind of fast to save time loading and presenting the stuff. Okay, so, I already did some values. Great. A function is where the domain, remember that's the x's, each entry, each number in the domain, it has exactly one value of y that it's matched with. Okay? Y's can match with multiple x values. Okay? So you can have an x, so you can have x equals 2 and y equals 5, and you can have x equals 1 and y equals 5 also, and that's okay. But each x cannot have two different y's. You can't have x2 and y1, and also x2 and x5. That's not a function. Okay, that's a little bit mysterious at first, but if we do some examples, I think it will become clear what we mean by functioning. If we set them up as mappings or graphs, it looks like this. You can get straight lines. You can also get x's that, let's see, if I had one more x, like if I have negative 5 and 5, that would be okay. Two different x's can go to one y's, but we can't have any forks. We can't have x equals 5, and that points to two different y's in the range. Okay, on a picture, that looks like a vertical line test. Any vertical line, remember vertical lines are x equals 1, x equals negative 1, x equals 0. That makes a vertical line, all the points where x equals 1. Any vertical line I can draw touches the function at only one point. Okay, for every x, there's just one y. Okay, there's no horizontal line test function, that's okay. You could have a function that fails the horizontal line test. So we use the vertical line test to say if it passes it, it has only one point, that is a function. If it fails it, and you have like the letter C, the cent sign, that's not a function. Okay, let's see. Oh, next slide. Oh no. Okay, combinations are allowed, like I was saying. The horizontal two points on a horizontal line is allowed. These are all functions. You can represent a function in a table, a mapping, an equation, or a graph. Similar to a relation, every function is a relation, but every relation is not necessarily a function. Okay, this becomes especially obvious if you think of a function as a candy machine. And the coins and the code that you're putting in, that's the x value, the domain, the input. And the treat that you're getting out is the y value, the output. Well, if you and your friend punch in the same code, you better get the same treat out, right? Or you'd say the machine is broken. Okay, so if you both punch in Funyuns and both Funyuns come out, that's okay. Now, if you both punch in the code and one gets Funyuns and one gets a candy bar, that's not okay. That was the same code, two different things came out, the machine is confused, and you're probably surprised it works at all. So that's not a function. However, you can have a function where two different x's, like these two different Frito stacks, come out the same. There's two different codes and they both get you Fritos. That's okay. That's working normally. That's still a function. So two different x's can have the same y, the same output, and you say it's still working okay. That's just we double loaded that one for two different inputs. We have the same output. That's okay. They still each have exactly one. Okay. There we go. Right, any set of ordered pairs is a relation. It can be a function, it doesn't have to be. If we have 1x, to 1y. For every x there's 1y, then yes it is. The opposite is if for 1x, whoops, if for 1x we have 2 y's, we have a fork. Then no, it's not a function. So, there we go. A function might be written in points like this. We could write x and y. We could also write y equals 5 times x. Okay, which is multiplying by 5. That's also a function. I don't know how to write it as an equation, okay, but these combos are okay. Double Fritos. Two different x's can have one y because each x still has exactly one output y. They can have the same one. No problem. Okay, this is not a function. Because you cannot have these forks in your mapping. Okay, if you put in 3, does 15 come out or does 20 come out? Is it random? How do we know? We don't know. Okay, so that's a not function. A machine that works that way is not functioning. Every time you click the same thing on your phone, you want the same thing to happen. It would drive you nuts. Okay, we can do tables and you can just judge them like on your homework. Okay, for each x, we have exactly one y. We have 3 different x's and 1 y's. Okay, we don't have any forks. You can draw them. Shh, shh, shh. Yes, that's a function. Okay, we have 2 x's and 2 different y's. So no, that one forks. Okay, this middle one is not a function. And this one is a function. Because we have different x's. They can all have the same y. We can have combos. Right, we could delete those, and that is okay. So on your homework, I'm just looking for yes, no, yes, no. You can draw the lines if you want to. If you need to, what do we do in ordered pairs? Okay. I have 2 different x's here that both equal 0. That's okay. Every x has 1 different y. Yes. In this one, okay, so what I'm looking for it not to be a function, do I have a repeated x? Oh, no I don't. So each x has 1 y. Yep, yep, they can have the same one. Yep, yep, yep. I can't have 2 x's, so they both are. Okay, my vertical line test. Draw a vertical line anywhere you want. Do you ever touch the thing in 2 places? You don't, it's just one? Then yes, it's a function. Okay, the parabola passes the vertical line test. It only touches in one place. There's no horizontal line test. If you draw a horizontal line and touch in more than one spot, you're still a function. Okay, that's the extra Fritos in the vending machine. It's okay. Circles almost always fail the line test. So that's not a function. A horizontal line is okay, it is a function. Just 1 point. A vertical line though, either I miss or I hit all the points. So no. Okay. There's function notation. It's just the same. We replace y as we say a function of x. We do that because then we could say like I plug in 2. If I say x equals 2, then the function of 2 equals 2 times 2 plus 5. I just replaced x with the 1, 2. Okay, and you can evaluate a function that way. It gets a little hairier than that. Okay, good. Try some examples. Real fast, f of 3, so that's 3 from the function, 3 from the x is replaced with 3 minus 4. 9 minus 4 is 5. G of x, so we could certainly do another function. Okay. Negative 4 squared minus 3 times negative 4. Okay, 16 plus 12 is 28. Negative times negative is positive. G of 0. Well, all those terms are 0. You can do an expression where you have the whole function. Maybe it's evaluated, maybe it's not. Plus 2. So you do 0 squared minus 3 times 0. Yeah, it's trivial. You don't have to write it out, but I still have a plus 2, so it's just 2. Okay. You can substitute another variable in. If I have g of x and I want g of n, that's totally fine. Just replace every x with an n. Maybe you want to combine equations later. You can insert an expression with a better color. I'm almost done. That's right. You can go next. Okay, so I have x. The function f of x was 3x times 4. So I'm replacing all the x's with k plus 2's. So I have a 3, and then I plug in k plus 2. Minus 4. We'll do some easy ones of those on the test. You have to distribute your k's. Your 3 in this case. 3k plus 6 minus 4. And you get 3k plus 2. We will practice these a bunch tomorrow. You can do, whoa, check this one out. The best color. Black. Okay, so I still have 2 times. I have to insert x squared in the function. So 3x squared minus 7. And then I subtract, oh, minus 4, excuse me. And then I subtract a 7. Okay, and then I just use order of operations. Hopefully you've, oh, distribute. You've mastered, oh, let's combine those two. Okay, 2 times 3x squared minus 11. Okay, then distribute my 2. 6x squared minus 22. Okay, we're getting a little long here, but we're almost done. Oh, board problems. Never mind. Okay. That's okay. Are they a function or are they not? Go back over the rules. Let's just substitute 4. Yeah, that's pretty easy. Oh my goodness. Okay. Don't be scared if you have to plug in something else. Whoops. It's never as bad as it looks. Okay. Everywhere there's a t, we're just going to plug in 2z. Replace the t with some parentheses and write the 2z in there. Okay, we'll practice a little bit tomorrow and you'll realize you actually have it down. Minus 320 z plus, that's going to be 4z squared. 16 times 4 is 64. And it doesn't simplify anymore. Okay, we don't know, we haven't been practicing operations like FOIL and stuff, so these won't get too terribly complicated. You won't have to plug in like k plus 2 and then square it. That's too easy. Okay, and I'll leave some time at the start of class tomorrow for you to ask questions. Thank you very much. Hope you enjoyed.